It's a beautiful day, let's call into work and we'll go out and play, sweet darling. 'Cause I've got nothing but time on my hands. I just wanna spend a little time with my man, sweet darling. You grab the rocks and I'll get the bait. We'll do a little fishing, let's make it a day with the blue skies above and the sun on our skin. Oh, sweet darling, let's go fishing.
Okay, I'm here today with Marisa Escobar. And so Marisa, the first question, how were you first introduced to the idea of ecohydraulics?
Okay, so I was thinking about that, and actually it's been a long path for me. I started in Colombia doing my civil engineering program, and in a country like Colombia, everything is about development. It's about building and constructing and just managing the landscape. And I was always like wondering, how can we do that better, right? So how can we do it so we protect the resources that are still, for the most part, very intact? So that was my interest in start thinking about environmental engineering and environmental issues. Then I moved to California to do my master's in environmental engineering at UC Berkeley. And there I started learning more about the hydraulics and the connection between the physical processes and the biological processes. And I heard the term river restoration, and that caught my attention. And that's how I started here at UC Davis, where I did my PhD program with you. Mm-hmm. And that's when I really started learning about the ecohydraulics. When I first learned that term, it made a lot of sense to me, because it's like all of these physical processes and how they impact the habitat. And going back to my initial thinking back in Colombia, I saw the contrast. Here in California, a lot of the ecosystems have been impacted. What you are trying to do is to recover that impact using the learning from the mixing of these disciplines, the ecology, hydraulics, geomorphology. And I always go back to Colombia and think about how we can do that better. Not only Colombia, in Latin America in general, where all of this development is happening right now. So that's my path to ecohydraulics, and that's why I think it's such an important discipline.
Yeah, okay. What's an example of an ecohydraulics research article that influenced your research?
So there's one that I always remember as being very important. It's the one by Maddock. It's called The Importance of Physical Habitat Assessment for Evaluating River Health. It's a 1998, something like that, article. And what was important for me in that article is that it compared like human health to river health, and how you need to be monitoring different parts of the system to know whether the system is healthy or not. And the other thing that I like about that article is that I share with my kids that I am a river doctor. And I think that's a good analogy, and they tell everyone that their mom is a river doctor, and that's how I think about myself.
Yeah, it's a very understandable way to help children understand what we do.
Exactly.
It's a big part of what ecohydraulics is about, I think, is like, diagnosing and helping to recover,
Yes, exactly. So I remember when they would ask me first, what do you do, Mom? And I was like, well, I am a river doctor. And I always had that image from that paper where he compares the two systems, and that's a good way of thinking about what ecohydraulics is too, for me.
What's a project that you're working on right now that relates to ecohydraulics?
So when I did my PhD, we worked more on the reach scale. My work professionally here at the Stockholm Environment Institute has been more on the watershed scale. So right now, what I'm trying to do is to connect these larger scale system representations two biological frameworks. So there are a couple of projects where we are doing that. The idea is to connect hydrology system operations model to a more detailed representation of what's happening in the different reaches. But that way you can see for different operation systems, not only the natural river or the natural flow regime, how does it create habitat, but for the managed system, how can you see the different levels of habitat creation that the different operation regimes can provide.
Mm-hmm. Just talk for a minute, because people may not be aware of like operations modeling.
Oh, okay.
The model that you use for that. And stuff.
Yeah, so here at the Institute, we developed the Water Evaluation and Planning System, the WEEP model. And what it tries to do is not only to look at the hydrology, but also the way the water is distributed and operated. So, for example, reservoir operations. You can see different flow regimes based on those different operations in terms of timing, water that's been released for different purposes, and how it's being allocated with different priorities downstream. Mm-hmm. So that's the kinds of operations that we can represent.
And so that can also then be used for environmental flow development too, right?
Yes, although I feel like the environmental flow, like for example in a model like this one, you can just prescribe an environmental flow and allow it to be with the highest priority, and then you are always complying with that environmental flow. Right. But that's not the reality, right? I mean, usually the environmental flow is the afterthought and it's the last priority, unfortunately.
Right.
So this linking, making a more, not only like this point where I need to comply with an environmental flow, but the whole system, how much habitat you are creating from upstream to downstream. And that requires a lot of assumptions. I mean, we cannot make a very detailed representation of the habitat at the reach scale. It's more like a system-wide representation of what levels of habitat you are creating throughout.
Mm-hmm. Yeah, that makes sense.
Yes.
I lost my question list here. Sorry. Okay. Looking to the future, what is one ecohydraulics topic that you think future generations will be better positioned to answer than we can do right now? So where is it all going?
I think that Ecohydraulics has done a very good job at understanding the dynamics at the reach scale. And that's very important, because you need to know how the amount of water with this shape of the river is creating different habitat spaces, right, for different in-stream species. That's very important, but I think it needs to be scaled up. So I really hope that all the techniques that have been developed can be scaled up, so we can really understand the habitat at the whole river, at the whole basin scale, so we can see really what is the habitat that is being created. And I think what we are doing right now goes in that direction. I don't think it's at the level of detail that it needs to be at right now, but I think that's the direction where things need to go.
Mm-hmm. And is there anything else you'd like to add for the community?
I think that it's very important for us to have a community of practice, to know that there are people that are working on these subjects, that we can collaborate. I don't think myself I know all the different events or things that happen on this subject, so I wish we could be more connected through Twitter, through other media, that we can just talk more and have a broader dialogue and learn from each other. And I think what you're doing is very good for that.